In our previous video of sets, we understood about the union of the sets, the intersection of the sets, the A minus B and B minus A, complement of A, subsets, and certain formulas of the same. Now we continue with exercise 6.1. We are done till sum number 5. We continue with sum number 7. So in sum number 7 we have got over here that the universal set is given as 1 to 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. They are given that A is equals to 1, 2, 3, 4, 6, 7, 8. B is equals to 4, 6, 8. Okay, these are the three things what I have given you. Now, they need to find out certain values of the sets. The first one is A dash. So, A dash will be automatically something which is not there in A but present in the universal set. So, it's 5 and 9. So, we can also see over here that, okay, before we write this, let's write down NA is equals to 1, 2, 3, 4, 5, 6, 7. NB is equals to 3. Then we say A dash is equals to 5 and 9. So accordingly NA dash is equals to 2. We have the second one as B dash, which is going to be 1, 2, 3, 5, 7, 9. So NB dash is going to be 1, 2, 3, 4, 5, 6. Third thing is A union B. A union B is going to be 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. Right? So it's exactly the A because all the things in A, B are there in A. Therefore, it is A. So we have got NA union B is equals to the same as A, which is 7. The fourth one is A intersection B. So fourth one is A intersection B will be B itself. That will be 4, 6, 8. A intersection B is equals to 3. We move to the fifth one. A minus B. A minus B will be equal to what is there in A but not in B. 1, 2, 3 and 7. So that's NA minus B is equals to 4. Sixth one. B minus A will be a null set because all the things which are there in B are present in A. So B minus A is equals to 0. A intersection B dash. We have A intersection B as A intersection B is 4, 6, 8. So B dash will be 1, 2, 3. It will be 1, 2, 3. 4 is there, 6, 5, 7, 9. Okay, 1, 2, 3, 5, 7, 9. So NA intersection B dash is equals to 6. Eighth one, A dash union B dash. So that will be A dash union B dash. A dash is 2, union B dash is this thing. So union will be 1, 1, A dash is 5 and 9. So yeah, 1, 2, 3, 5, 7, 9. So N A dash union B dash will be 1, 2, 3, 4, 5, 6. Now let us see certain kinds of the verifications what they want. So let's see one by one. First one is A intersection B dash is equals to A. So A intersection B dash is equals to A dash union B dash. You can see A intersection B dash is nothing but A intersection B dash is this one, 1, 2, 3, 5, 7, 9. And A union B dash is also the same thing, 1, 2, 3, 5, 7, 9. So it is over here 1, 2, 3, 5, 7, 9. And here also it is 1, 2, 3, 5, 7, 9. Hence LHS is equals to RHS. Second one, NA plus NA dash is equals to N universal set. Now universal set over here, N universal set is equals to 9. A is 7, A dash is 2. So it is 7 plus 2 and here it is 9. Therefore LHS is equals to 9 is equals to RHS. Okay. LHS both is equals to RHS. That's this part over here. Now the next one. So let me do one thing. I'll just erase this part so that it's not a problem. Because what we read over here is all N ka part only. So we'll have the N ka part. So it's the C part. This was B and this was A. C part is NA intersection B plus NA intersection B dash is equals to N universal set. Again the same thing. NA intersection B. NA intersection B is 3. NA intersection B dash is nothing but NA intersection B dash is 6. And this is 9. So is equals to 9. So LHS is equals to RHS. We see the D part. That is NA minus B, A minus B, NA minus B plus NB minus A plus N intersection B plus N A intersection B is equals to N A union B. So we have got LHS over here as N A minus B. What is N A minus B? A minus B is 4, B minus A is 0. So it's 4 plus 0 plus A union A intersection B. A intersection B is 3. And whereas RHS is equals to A union B is 7. So here it is 7 and 7. So LHS is equals to RHS. Is it clear? So it was a very easy thing if you once understand what is the B dash, A minus B, B minus A intersection B, A union B dash, A intersection B dash. So if you know all these, then we are just going to find out what are the cardinal numbers of those sets. Cardinal numbers are that number of elements present in that set. So accordingly we see over here, my A dash was 5 and 9, so cardinal number 2. B dash is 1, 2, 3, 5, 7, 9, cardinal number 6. A union B was this, so cardinal number 7 is 4, 3, 6, so 3. Accordingly, when we are proving it, what we are having is A in here, there was no N, so we are just having the direct values. So direct value was A intersection B dash. What is A intersection B dash? We already found out A intersection B dash as 1, 2, 3, 5, 7, 9. So this is 1, 2, 3, 5, 7, 9. And we also found out A dash union B dash. A dash union B dash was what? A dash was written over here. This is A dash, this is B dash. Dono ka union will be A 1, 2, 3, 5, 7, 9. You can see this is also 1, 2, 3, 5, 7, 9. This is also 1, 2, 3, 5, 7, 9. So LHS is equal to RHS, hence proved. In the next one, we have NA and A dash. A was 7, which we just erased because it was given over here. And cardinal number of A dash is 5 and 9. So only 2. So we get that LHS is, I need to write down, sorry, I left out over here, LHS, this is RHS. So this is 9 and this is also 9. Here also LHS and RHS. So this is 9 and this is also 9. Accordingly, we have that LHS is equal to RHS, hence proved. Here also the same thing. This plus this is 4 plus 0 plus 3 is 7. This is also 7. So LHS is equal to RHS, hence proved. So this was sum number 7. Okay, we now move on to sum number 9. Okay, we have sum number 9. NA is equal to 20. NB is equal to 16. And A union B is equal to 30. You need to find an A intersection B. Okay, so this is purely formula based because we know that NA union B is equal to NA plus NB minus NA intersection B. This is a formula which we had written down earlier in the last previous video. So based on this formula, we have got A union B is equal to NA plus NB minus NA intersection B. So bringing this over here and this over here, we get over here NA intersection B will be equal to NA plus NB minus NA union B. And A is equal to 20. This is 16 minus 30. So it's 36 minus 30 is equals to 6. So NA intersection B is equals to 6. Clear? That was sum number 9. We move on to sum number 11. N universal set is equal to 40. NA is 20. NA 20 and B dash is 16. And A union B is 32. Okay. And finally, we need to find NB and NA intersection B. Okay. So first is this one. For this we will use the formula that NB plus NB dash is equals to N universal set. It's always going to be this way, that a set and a complement of the set gives you the universal set. So NA plus NA dash or NB plus NB dash will give me the universal set. So that gives me over here NB plus 16 is equals to 40. So NB is equals to 40 minus 16 is equals to 24. So NB is equals to 24. Now this one, we know that NA union B is equals to NA plus NB minus NA intersection B. A union B is given as 36 is equals to NA is 20 plus NB is 24 minus NA intersection B. So that gives me NA intersection B is equals to 20 plus 24 minus 36 is 44 minus 36 is equals to 8. So NA intersection B is equals to 8. That was sum number 11. We now move on to sum number 13. There are multiple questions in this one. So sum number 13, we have got universal set as 40 and universal set is equals to 40 and A dash is 15 and A dash is equals to 15 and B is 12 and N A union B dash is equals to 4. Sorry, 40, 15, 12, A union intersection B dash is 32. Sorry, intersection B dash is 32. We need to find out first one, NA. So for NA, we know that NA plus NA dash is equals to N universal. So NA plus 15 is equals to 40. So NA is equals to 40 minus 15 is equals to 25. The next is NB dash. So NB dash के लिए NB plus NB dash is equals to N universal. NB is given as 12 plus NB dash is equals to 40. So NB dash is equals to 40 minus 12 is 28. Third one, NA intersection B. NA intersection B. We are giving B dash. So again the same thing. NA intersection B plus NA intersection B whole dash is equals to N universal set. NA intersection B I don't know. This is 32. So NA intersection B plus 32 is equals to 40. Therefore NA intersection B is equals to 40 minus 32 is equals to 8. Okay, we move on to the fourth part. You can see over here that the formulas what we learned earlier what were very important. If I don't know the formula, I cannot do any of these sums. Formulas very important. The formulas, the 5 formulas what we did earlier, we wrote earlier in the previous video are very important. You need to learn them by heart. Only then you can solve this thing. You will not know this thing. They are not given anywhere. See, in the earlier sum it was to prove that. To prove that this is given, then it's not a problem. Because at least this I can find out, this I can find out, and this I can find out that these are equal. But here I don't know this formula at all. The formula is not given to me. This formula is not given to me. This formula is not given to me. Okay? So, mind well that you remember each and every formulas properly. So, next one is NA union B. So, the fourth one is NA union B. Now, the formula for that is NA union B is equals to NA plus NB minus NA intersection B. Now, NA we found out to be as 25, NB is given to me as 12, and NA intersection B we just found out to be 8. So that's why it is 37 minus 8, that is 29. So NA union B is equals to 39. You see the fifth one, that is NA minus B. Okay. So for NA minus B, we will have to take the formula of NA minus A intersection B, or I can take NA union B minus NB. So we'll take this one, NA minus NA intersection B. So NA minus B is equals to NA minus NA intersection B. NA is 25, intersection B is 8, that's 17. Okay. The next one is NB minus A. NB minus A. So NB minus A is equals to NB minus NA intersection B. Okay. So that's NB is nothing but 12. And this is 8, so it's 4. So NB minus A is equals to 4 over here. So here we got the answers for the sums 6.1 as, let's check it out. This was sum number 13 as 25, 28, 8, 29, 17 and 4. Clear? So this was your exercise 6.1. Right? These sums being a bit tricky, I will do the 14 sum also, so that cutting off on your homework part. So we'll do the sum number 14 also. Sum number 14, and A minus B is equals to 12 and B minus A is equals to 16 and A union B is equals to 5. You need to find out NA, NB and third one is NA union B. Huh? Union B? Oh, sorry. This is the intersection. Right? So we have these things. So we have the intersection and we have A minus B. So we can use the this formula we used earlier. So there's two formulas we can use to get A and B. So let's take the first one. NA minus B is equals to NA minus NA intersection B. So that's A minus B is 12, NA is what I need to find out, minus A intersection B is 5. So it's 12 minus 5, 7 plus 5 is equals to NA. So that is NA is equals to 17. Same way for this one, NB minus A is equals to NB minus NA intersection B. Got it? This formula very, very important. Okay. So NB minus A is going to be a 16. So 16 is equals to NB minus A, that is B, sorry. NB minus A intersection B is 5. So 16 plus 5 is equals to NB. So NB is equals to 21. You see the next one, the last one, A union B. Oh wow, this is exactly the same out here. So next is A union B. So the third one, this was the first one. The second one is the third one. A union B is NA union B is NA plus NB minus N intersection B. A we just found out to be a 17. B we found out to be 21. A intersection B is 5. So that's 38 minus 5. It's 33. So N A union B is equals to 33. That was sum number 14. Let's check up the answers. So sum number 14, the answers are 17, 21, 33. 17, 21, 33. Perfect. So this brings us to the end of the sets. We now go to the next video for Venn diagram. So of course it's a part of the same chapter, but we'll take it as a separate video so that there is no confusion between the two videos. So we will go for the next video for Venn diagrams.